Hey guys, this will be quarter two. We're going to go through and do our quarter two project. Quarter two project is about graphing a polynomial, and to do that we're going to have to insert some very specific information or read the certain information from our equation. So all of these equations, 1 through 30, these will be your calculator number, or if you get assigned in Mr. Henry's a different way, that would be assigned however that is. But I'm going to give you your calculator number 1 through 30, and the way that we're going to do this, we're just going to pick one. I'm going to build my own. Remember, all these f of x's are the same as a y equals. You can think of it as y equals, let's go with negative x minus 3 squared x plus 4 x minus 2. That's too close together. Let's go x minus 8. And then how about an x plus 1? We'll call it that. All right. So there's my polynomial. I need to go through a list of very specific things you're going to be asked to find. The first thing that you're going to be asked to find is the leading coefficient. Now the leading coefficient is really this number right in front of here. Now keep in mind, guys, right now I'm starting what I would do for a video. If I was producing a video, I would start right here explaining every step of this as we go through the process. Okay, I decided I don't like that thin pen. All right, so the leading coefficient is negative, as we can see from that symbol there. So think of it like a -1. All that matters, though, is that it is negative. If there's no sign there, I'd assume it's positive. The next thing we look for is the degree. The degree of the polynomial is the biggest exponent. But when it's in factored form like this, I have to think of what would happen if I multiplied all these x's together. Well, it turns out it's just the same as just adding up all of the x's. I see one x there. I see another x. That's 2. Here's a third x. And here's the fourth x, but because it's squared, I'm going to count it twice. So if I FOILed all this stuff together, I would end up with x to the 5th degree. Okay? Now what really matters here is that that is odd. Okay? That's going to help me figure out my end behavior, which are the two arrows on my polynomial, the left arrow and the right arrow. Because the leading coefficient is negative, the right arrow must be down. And because the degree is odd, the left arrow will be the opposite of the right arrow. So right arrow is down, opposite of that would be left arrow up. Now I need my zeros. Now the zeros are really easy to find. They're just the things in front, they're just the opposite of what's grouped with x. So this says x minus 3, so I'm going to use a positive 3. This says x plus 4, so I use a negative 4. X minus 8 uses a positive 8, and x plus 1 uses a negative 1. Now multiplicities, not everybody's going to have a multiplicity in their equation. It's really about whether or not there's a parentheses squared or a squared value. So you can see that right here. I see that x minus 3 is quantity squared, so that means there's a multiplicity at 3. Now keep in mind, guys, there are also multiplicities and things at like this x right here without anything with it. We assume that that's at 0. Okay, so if you get one that has a plain x somewhere in it without a minus 3 or plus this, we can assume that that's at 0. And we have a multiplicity if that's squared or any of these others that has a square on it. Not everyone does. So if you don't have a multiplicity, just say that you don't have a multiplicity. The last thing we're looking for is the number of turning points, which is always one less than the degree. And since my degree is 5, there would be 4 turns. Okay, this should be enough for me to produce this graph on a piece of paper without using a graphing calculator. It'd be pretty quick. I'm going to have a 0 at -1, a 0 at -4, which would be way out here. I'm going to have a 0 at positive 3, and out here at 8, 4, 5, 6, 7, 8. Now, one thing that I always talk about is I like to put, if I have a multiplicity, I like to identify it by putting in a little dotted circle around it. I call it the Welch indicator. You can call it what you want. But the point is, when I hit that spot, I'm going to have to bounce instead of passing straight through. Now that being said, my left arrow should be up, and my right arrow should be down based on the end behavior I already drew in. So I'm just going to go ahead and draw the graph. I'm going to come down through -4. That's my first 0. Then I'm going to turn at some point and come back up through -1. I'm going to come down to positive 3, but instead of passing through, because it was a multiplicity, I'm going to bounce up and eventually work my way back down and through at positive 8. There's my polynomial graph and all the information that you needed to do it. Good luck, and we'll see you in class.